Let's talk about correlation when we look at scatter plots. Many of you have been having difficulty being able to look at a scatter plot, such as this one, or this one, or this one, and being able to determine whether or not it has correlation or what kind of correlation it is. So one of the things I want us to look at is what correlations look like. So if you look at this scatter plot, okay, notice that the points pretty much are consistently going up from left to right, right? We read a graph left to right just like we read words. Because this is continuing to climb in a pretty steady pattern, it's not totally in a straight line, but they're clustered together quite well. This is an example of a scatter plot showing positive correlation. Now look at this one. All of these points, they're not totally in a straight line. They are scattered about a bit, but in general, they're going down, again from left to right. That's how we read a graph, left to right, just like we read our words. And that's why this one is an example of what we call negative correlation. But now look at this third one. This third one, the points are everywhere. They go up, they go down, they go back and forth. It's kind of flat. It's kind of like a big burst of rain, a cloud. This one has no correlation because you can't see a consistent pattern of either the points going up from left to right or going down from left to right. They're just scattered everywhere. This one is no correlation. Now let's talk about how to get a trend line. Your teachers have been showing you what they call the hot dog method, and this is a nice, simplistic way to look at it. See how nicely this positive correlation is laid out? If I was able to just take and put an oval around this, right now that kind of looks like a potato, but I just want to draw that line through that circle to create the split in my hot dog bun, right? So it's not great, it's not perfect, but that shows, in general, the steepness of my correlation. And if I look, I have 1, 2, 3, 4, 5 points that are above my line, 1, 2, 3, 4, 5 points that are below my line. Now what I could do if my teacher asked me to is I could look for 2 points that look like they are on this line. This point looks like it's on the line, this point looks like it's on the line. And what I could do is use those 2 points and I could plug them in to my y equals mx plus b form, and I could find the equation for my line of what we're calling a best fit. I could also use this line to make predictions about my data. Alright, so now let's put in our labels. I went by 10s on this axis and I went by 1s on this axis. Let's say that this axis represents the number of people and this axis represents the number of widgets per person. So I could make a prediction and I could say, well, if I didn't have any data on that particular place and I wanted to know how many widgets there are for every 6 people, I would follow my eye up to my line of best fit from the 6, and then I would follow my eye across, and it looks like somewhere between 70 and 80 widgets should happen for every 6 people. So I might tell my teacher I think it's approximately 75 widgets. Don't forget to give a label whenever you work with this kind of information. Now what if instead my teacher said, well, if I have 40 widgets, how many people should I be able to work with? I'm again going to follow the 40 over, and then I'm going to come down, and I know that between 3 and 4 people should happen in whatever this instance is for every 40 widgets. Let's try our hot dog method again for our negative correlation. So I'm just going to draw a nice circle around my data, and I want to be able to draw a line which splits my data fairly well down the middle. So remember, I'm trying to create that split in my hot dog bun. And I have 1, 2, 3, 4 dots below, 4 pieces of information. 1, 2, 3, 4, 5 dots that are definitely above, and a couple. So when I look at my data and I count, I have 1, 2, 3 points that are definitely below. This one's kind of sort of below. And then 1, 2, 3, 4, 5 points that are above. So this is probably not the best line of best fit. It probably should be scooched over a little bit more or pass through a couple more of the points to even out. But this is pretty close. It's not too bad. And again, what I could do is take a couple points that are on the line. Well, there's a point for sure. I went through that one. And then it looks like this point right here. And again, I could use the y equals mx plus b form to write myself an equation to represent my line of best fit. And remember, when I want to read my line of best fit, I do my best to draw vertical and horizontal lines from my axes, either with my ruler or with my eye, or just freehand it like I did here very carefully. But I want to show my instructor how I read that graph and how I chose the piece of data that I did. Now remember, we can't do the hot dog method to a no correlation. If there is no correlation, we can't draw a line of best fit. But we need to communicate that to the teacher, whether it's on a homework or an exam, that, I'm sorry, I can't do a line of best fit. There's no correlation to my data.